At JPL, we've been developing some really cool software called Eyes on the Earth, which is essentially an interactive algorithm that lets anybody see real-time events around the globe. Here with us today is Jason Craig. He's the producer of this software. Howdy, Jason.
Hi, Mike. Thanks for having me.
No problem. Can you tell us a little bit about the software?
Sure. This is a public outreach piece of software that anyone in the world can use with just a web browser. So our mission is to show visually what Earth science missions are doing and where they are at right now. So this is a real-time product. So everywhere you see a label here, these are actual Earth science missions in their current position. And more than that, we can actually take the data and put it right on the globe visually. We put in a lot of different missions and their data sets. So let me show you the list of data that you can get right now and put on the globe. So we have air temperature, carbon dioxide, carbon monoxide.
So we're looking at carbon monoxide overlaid across the entire globe here.
That's correct. And this is the last 3 days, and the software will continuously update as you open it. So for example, the mission that's creating the data is always shown on Eyes, in this case Aqua, and the AIRS instrument. And so you will see where there might be fires around the Earth, for example. You can also animate the data and go back in time and see it in the past. Let me show you another data set. Jason 3 sea level. And you can see a monthly map, in this case, January 2022. And you can see where the sea is higher than a previous monthly average and lower. And in this way, you can see things like El Nino, which you may have heard about on the news, which means we might get more moisture in certain parts of the world. So we want to make things visually intuitive. So if we're talking about sea level, we want to color code it. So you have a legend right here, and you can see it's in millimeters, so it doesn't sound like all that much. But when you get to the white part of the legend, you can see the sea is almost 20 centimeters higher than normal. That doesn't sound like a lot, but when that sea is warm, it really creates extra moisture and humidity, which can affect weather patterns.
And if people tune in every day, every week, will they see changes in this spread?
They will. Another important point is this is the actual data from the missions themselves. All we are doing is putting them in a visual format that is more easy to understand.
So everyone around the world can have the exact same data that the scientists themselves have.
Exactly. For all of these vital signs, you can look at the legend on the bottom, and this will tell you this is the concentration in parts per million of carbon dioxide. As you know, carbon dioxide is a crucial climate change driving molecule because it tends to oppress a certain wavelength of light inside Earth's atmosphere, causing what is referred to as global warming. But here you see that it goes from 390 parts per million to 415. And over time, we're seeing it go up. If you look now, it's actually off the chart.
So this is a list of missions that we can click on.
Sure. When you click on one of these missions, you'll see where it is this very second, real time. And let's try one. Everybody likes the International Space Station, so let me just select that. It'll load it up in its current position, and in you go. So here is the space station in its current position around Earth.
So what we're looking at here is a CAD rendering of the ISS itself, but everything about it is real. It's a real-time event, wherever you are over the globe and its orientation, and you can play around with that and rotate that entire thing.
That's correct. You can also speed it up, and you can watch the solar panels track the sun over time,
Very cool.
which is not obvious in everyday pictures.
So this is showing the GRACE follow-on mission. It's measuring gravity changes across the globe. Tell us a little bit about this. Is it the same as the ISS where you're looking at real-time spacecraft information?
This is still real-time information. We can gather up the gravity fluctuations over the planet Earth and visualize them. And it turns out the principal driver of mass change, which is what this is measuring, is water and ice movement. Let me show you the data set. So GRACE follow-on, we have another colorful map as before, but over time, you can learn through the legend that there's more water on the purple to blue areas and less water on the red areas. So for example, in Southern California, you can see it's red, which means there's less water than the previous baseline. And if we go back in time, we can see that that has been red for some time. But you can also see the fluctuations in the season. So for example, in the Amazon, you can see it go back and forth, red to purple, red to purple. So rainy season, dry season. And it's really cool to see that visualized through gravity itself.
And users at home can scroll through huge periods of time to see those changes.
Yes, for this data set, they can do 10 years or more.
Very cool. Can you tell us briefly, viewers at home, how they can get on right now and check this out?
Sure, just go to eyes.nasa.gov, kind of just like your eyes, and then it'll be a banner there, and you just click on it, and it works on your mobile phone, your tablets, your laptops, your desktops, anything with a web browser, Linux too.
Very cool. Jason, thank you so much for your time. Hope you guys enjoy it out there.